my old friend. How are you?
Good. Nice to see you again. The picture is pretty funny, the one on the present day.
I know we got a new picture for Ken, but he, for whatever reason, he likes that. And to be honest with you, that was when I was at one of the happiest times of my life. There was on a beach in Cape Cod with my kids running around playing. So I enjoy looking at it because it brings back some wonderful memories that I had from a distant past.
I look a little cuckoo. It's not that I'm not, but.
So anyway, I'm excited to see you back. Love to have an update from where you're at. I know you moved back about a year ago from Spain.
Mm-hmm. 1 year.
You're living in the East Coast of Canada.
Yeah, Toronto. I'm back in Toronto in the house that was before. So, yeah.
Nice. And I wondered if you've gone ahead and push some new phases to the system, or is it pretty much you figured that out and you're just putting the final stages on?
I had the time to complete a lot of the ideas and kind of also validate a lot of the potential markets and potential clients. I looked at truffles. We talked about this in the last podcast. I looked at trees for the first time with two potential customers in Europe. I didn't consider trees at the beginning. Trees require a lot more water than the smaller, let's say, potted plants, or edible, plants and
crops.
Just 90-day crops. So for trees, yet there's additional challenges in terms of scaling the product, but the product is basically the same. Just the pumps need to be a little bit bigger for the watering requirements of an orchard or whatever. So the product design is going to be the same regardless of the capacity. So it's already set, and we finished that. So I have a first product that I can actually build, and certain parts of it we could probably customize with not a lot of effort for different water requirements, but generally speaking, the architecture is going to be the same, and the product is going to wind up looking very similar. The current product or the current design, let's say the design that I'm going to start producing in the short term, is appealing for both indoor and outdoor grows, and the materials can also withstand outdoor conditions, and be left basically, set and forget somewhere, as long as there's some power source. The pump units obviously require a little bit more power to operate, but the plant units, the one that actually distribute the water, can work with a solar cell and doesn't have any batteries or anything. So in that sense, it could scale for trees. So and I analyzed, actually, I did some work and researching into applications for trees, not for the tree itself, but for the truffles growing in the root system of these trees. Obviously, this applies to the tree itself as well, but in a minor degree for that application. But other applications that we've discussed, you and me, for trees and potentially like pistachio and other nuts. The water requirements are much higher than the product can handle right now, but we can scale the pumps accordingly, and the rest of the system will be identical. So if you want to see, I have a short presentation.
Yeah.
What's the idea behind crop steering? These are things we covered before, but it's always good to refresh those concepts. And then I have some light specs there. Obviously, it's not This is not formal commercial brochure or anything like that, but it gives a much down to earth feeling what the product is and what it looks like. So
Fantastic.
I can switch the slides here. Okay, cool. So the product has been designed from day one for carb steering. This is something that we've talked about from the very beginning. And one of the challenges is carb steering with water. Water is one of the strong ways of steer a crop. Um, and in any grow, you want to balance the the leaf and stem ratio to whatever you're producing in a way that you have just enough um, leaf and stem to produce the highest um, the highest yield of the product, whether it's resin in cannabis or it's you know the pistachio seed or whatever, the flower in the in whatever crop. So there's a point where you want to take the plant and stop the vegetative state and steer it towards the regenerative state, and that you can do very easily with water. Um, and also the water requirements can vary considerably between one stage and the other. And the pistachio tree, I was doing some research. There's basically like two big seasons, and the water requirements shift dramatically um, from one stage to another. So all these things can be accomplished, and they're all part of crop steering. You can generally crop steer through temperature, humidity, um, and water, basically. And there's certain, let's say, guidelines into the vegetative state and the regenerative state, and these are well accepted, let's say, guidelines for steering the crop one way or another.
And to be honest, you've done a lot of work on this over the years, and
Yeah.
this is your understanding of how best to do it, which is important to illustrate.
Yeah, one of the things is that generally with irrigation it's not part of the crop steering strategy, and if it is, it's manual and requires a lot of labor. What this product does, it fills that gap exactly. Um, yes, you can should automate certain things. There's certain products that work, uh, better or worse than others, but this one you can dial in exactly what you want to do, and it'll automate the whole irrigation um, for you. And it's point by point. It's not drip irrigation, or it's micro irrigation with peristaltic pumps specifically to each plant or zone. Okay. Um, so again, if you're working in controlled environment, all these things are very easy. If you escape the controlled environment and start growing like in soil, especially outdoors, or you want a more natural environment, you have less control over the variables, right?
Yep.
One variable that you do have full control over is irrigation. One good example is the truffle thing that we were talking about before. The yield of the truffle is directly proportional to the summer rain pattern. And that's been proven over and over with all these studies of the cores in trees, and they can map out, specifically how it rained in the summer, where will in not one summer, because the truffles take years to grow. Um, but the summer rain patterns directly affect the yield of the truffle. Um, and it's not a lot of rain, it's not a little rain, it's just the right amount of rain at the right time. So because weather patterns change and you don't have control over the rain, the system that we've developed allows you to compensate for that. Either you know you hold back on irrigation, or you irrigate based on whatever conditions you want to program into the system. So that's exactly what we're after: precision, point by point irrigation. And it's not applicable for every grow, but it is a unique value proposition if you want to crop steer, um, for, to develop, either specific traits of the final product. They're called phenotypes. You want to manipulate how the genetic expression of the plant. You can do that through watering and other conditions. So it's really meant for, like, I would say, boutique growing, or in the case that you need to save, a lot of water. This is another um, great application for the system, because this is probably as efficient water-wise as would be, I would say, even aeroponics. So it's a really efficient way to save water if that's one of your concerns. The final product right now is it consists of two units. It's a pump unit that has the let's say the brain of the. It's like a central command system, um, and that pump unit is able to control 8 of the plant units. It has two peristaltic pumps inside, and it has the control and radio to communicate with the plant unit, and the plant unit can distribute water for 8 plants. So one complete pump unit can do up to 64 plants in groups of 8. That means that it can control 8 plant units.
So, Alex,
Yep.
can you exchange the pump unit and turn it into like a servo where you can turn the irrigation on or off? Because a lot of these big commercial facilities, they have street pressure, so it's just a matter of turning it on or turning it off. Is that something?
So this system is designed to be ultra low pressure. So ideally, first of all, you want to rest your water, right? You don't want to use the water directly. Well, generally speaking, you want to get the chlorine, at least chlorine evaporation, out of the tap. So the pump unit is designed to feed from a tank gravity-wise.
Okay.
So you can have one central tank. Just normally, the way you would set this up is you have one central tank feeding into several pump units in an area. Um, let's say we have a setting. Let's discuss trees. Trees is a good uh, way to see this. Let's say you have let's say we can do trees that are, what, 6 meters apart.
Yeah.
More or less. Just the oak trees in in Spain that do the truffles are about 6 meters apart, I think. Um, that's from the canopy to canopy, I think. It's not trunk to trunk, or it might be trunk. No, it can't be trunk to trunk. It has to be canopy to canopy, I think. So you would place one. So for 64 trees, it's going to be radial, right? Uh,
Yep.
let's see the slide here. So this would be there is a distance limit, electrical limit, from this unit to the tree or the plant. These sensors come in 2 wire sizes, and you have to choose one or the other, because the electrical signal is going to be different depending on the length of the wire, right? So there is a limitation here. It is several feet. Um, for Radially, you should be able to get to all eight irrigation zones um, within a certain amount of feet. Um, let me see. I'm going to um, hygrometer. I'm going to check the. I don't have the exact dimensions of that wire, but there are 2 sizes. They come in a short and a long wire. Um, specs. Ah, Here we go. Let's see if we can find it real quick. Um, Watermark. Watermark sensors. They come with 2 lengths of wire, if I'm not mistaken. Again, this is like
Hey, you don't have to get hung. You don't have to get hung up on the exact.
no, I don't. Yeah, but it's a few feet. I think there's a 3 or 6 feet probably radially. So I think there's two main sizes. One is 3, the other one's double. Um, in any case, the the pump unit does have to have there's a distance limit on the wire. Okay. Our sensors can do both sizes of the wire. I believe it's 3 and 6 feet. So there is some limitation there. Um, so the plant unit has to be radially within reach of whatever zone, but water-wise, not so much. So water-wise, we have more leeway. If it's a plant, usually have one drip emitter, or you have a ring. If it's a tree, you probably want to irrigate around the drip zone of the canopy.
Yep.
With an irrigation ring, that would be ideal. So irrigation-wise, it's not so much limitation. The main limitation that I see is the distance of the wire for the aerometer sensor,
Yep.
and the depth that you want to put it at. But this is the current layout. Now, this doesn't mean that we can't change this for specific tree applications.
Yeah, modified.
Yes, and it's not that complicated to rearrange it.
Well, that's the beauty of the system is that you made it very adaptable to almost any type of growing.
Yeah, we can probably change this around a little bit. Look, the nice thing is that the right hand unit, the one you see on the right hand side, the plant unit is very low power. So there's no wires involved. You don't see any wires from the plant unit to the pump unit. The pump unit obviously requires more power because it has the pumps. But the valve that operates inside the right hand unit is completely powered. It can be completely powered with a solar cell. The board and the radio is ultra low power as well. So if we need to split this, it's not it's not a huge lift to reimagine this piece and split it in a way that we're not limited by the distance of this wire. But there is a physical limitation from the plant unit to wherever you want to sense. But this is basically it. The left hand one that you see on the screen can control 8 of the right hand ones.
And the thing that's connecting the square to the circle is the water line.
There's just 1/4-inch water lines. Yeah.
Yep.
That's it. There's nothing else that goes. Everything else is radio communication between the two, and the plant unit monitors the plants or the zones, and then it sends the irrigation requirement to the pump unit. The pump unit schedules it based on whatever criteria the operator programmed into the system. There are basically 3 parameters. One is what is the dry point where you want to start irrigation. That's measured in centibars. This sensor can go up to 200 centibars, which is quite a lot. Um, this is the same. The sensor is identical to a
Barometer.
uh, aerometer. What do you call it? Not the aerometer is the brand, but the what is it?
It's
Tensiometer. Tensiometer.
tensiometer. Yeah, there you go.
There you go. So this is an electronic tensiometer, basically. Okay, but regular tensiometers can measure maybe the low tension ones can measure 0 to 40 centibars, and the high tension ones can measure maybe to 100, maybe 150. This can do up to 200. So basically, this is an electronic version of a tensiometer, and it lasts um, several years underground, a couple decades maybe. It can last a long time under the ground. So it's not a disposable thing. It lasts many years. So you can just set it in the ground and leave it there, and it simulates a root. And then this plant unit is able to read the 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 water potential exactly at that sector wherever the sensor is, and that signal will trigger the irrigation. And then you specify the number of shots that you want to irrigate and the amount of total water on that spot. So when it reaches that set point, the number of centibars that you set, it will start irrigating. It will divide, if you said, I don't know, 7 liters total, it will divide those 7 liters in the amount of shots that you specified. Usually, you want to do incremental or like a logarithmic um, size of shot to avoid water spill from hydrophobia, right? Because when the soil is too dry, you put the water in it, it just spills away.
Yep.
So you want to do a little bit at first, then the second shot you want it to be a little bit bigger, and the third shot, and then after that, you could probably. So you have to experiment and kind of fine tune the system to find out what the optimal amount of shots is at that centibar level. If the soil is too dry, it will be hydrophobic at first. So you want to irrigate just a little bit, and then wait, and then irrigate again. So you have all those parameters you can tune into the screen, and tell it the number of shots, the weight between shots, and the total amount of water you want to irrigate, and then the system will distribute this irrigation. It will be stochastic, right? It will be random because we're not polling, we're actually reacting to the environment. So the system is not like polling it. Well, it is polling the plant, but only the cue, so to speak, will be distributed because it will be triggered by the plant itself. So you won't run into a situation where you're only going to irrigate just the first few plants. It'll be well distributed amongst all the plants. In this case, 64, right? The maximum amount of plants for this unit. They'll be irrigated in a random pattern. So you should get an even distribution amongst the shots. So it'll do one shot here, and then it'll go to another plant, do another shot, and it'll come back around to this one and keep going until it fulfills a complete. It keeps track of each one until it finishes.
So this way, it never slows down. It's constantly.
So as long as there's light, yeah, it's designed really to irrigate during the light because this unit is designed to work with a photocell. So as soon as there's in many scenarios, you want to wait even maybe 1 or 2 hours after sunrise, and stop watering maybe 2 hours before sunset, right? Um, so this unit will have a photocell, and it can activate when it detects sunrise. It'll start charging and activating the irrigation the irrigation cues and send the commands over to the pump, and the pump will start irrigating based on an even distribution of water. So it'll start just working one and the other until it completes all the irrigation requirements that were programmed into the system. Um, okay, so this would be the minimal system would be one pump unit, one plant unit for 8 plants. That would be like the minimum purchase unit, right? That would come with 8 sensors, this plant unit, and the pump unit. The pump unit, obviously, you can expand it up to 8 of the plant units for a total of 64, and that's hence the name of the product. How'd you get 64? Because one pump unit can do 64 plants.
Gotcha.
Eh, the the pump units as such can work in tandem in a complete system. They can communicate with each other over a Wi-Fi backbone for up to 4,750 of these. Um, and that will give you a total of 304,000 individual zones that you can irrigate. So you can scale the system up, and the limitation here is the network. It's a radio network. It has a limit of channels. So to avoid interference, um, there's a limit to the communication channels, and that's why there's a limit here. So that's the total limit of the system is 304,000 points. The current, sorry, go ahead.
No, I said gotcha. That's significant.
Yeah, I don't think many of these within a few, maybe tens of thousands, but I don't think we'll ever see a fully developed 304,000. I wish, I hope so, but okay. The current dimensions of the peristaltic pumps are designed for medium-sized grows. Tomato, cucumber, cannabis, mostly CEA organics, typical grows. So the current irrigation capacity of the relatively small peristaltic pumps, each pump can do 30 liters per hour. So that's 7 liters in an 8-hour period for the 64. For a total of whatever that multiplication is. Times 64. I won't be able to do that one in my head. So
don't worry about it.
Times 64. Yeah, so you can do about 450 liters in an 8-hour period for the 64 plants. That's the current, let's say, scale version that I'm going to production with, which satisfies the majority of non-trees. 90-day grow plants. Let's see what else. I already talked about this. Well, the secret sauce is keeping it. The product is very cost effective because the distribution is not done with solenoids. It's done with a rotary selector valve, which is a patent that we own, and that's the secret sauce. It's the valve, that multi-point valve that can operate with a very low power servo, so it makes it very cheap, or cost effective to fabricate, and hence that it keeps the price of the product down enough to scale, and that's I guess that is the whole the whole invention here is doing individual zones in a way that is feasible economically. Okay, you couldn't do this with solenoids because it would be prohibitive in terms of cost, right? So the system is able to achieve it because of the diverter, which is our secret sauce.
And that diverter could be created bigger based on larger scale irrigation systems, correct?
The diverter right now is like 3/8 of an inch in diameter. So, but it's designed for ultra low pressure. So ideally, you what we want to scale is the peristaltic pump. We want to scale volume and not pressure. And at 3/8, I think it would be more than enough for trees. Um, and But we do need to scale the peristaltic pumps for sure.
Well, again, if you don't need a pump if you have street pressure, you just need your secret sauce. You just need the valve. If the valve is opening and closing based on, and think of it this way, like Alex.
Yeah, for sure.
Yeah, so think of it this way, right? You've got 300 trees in a row. That's one year. That's one zone, and they just go on and on and on and on. So the key in scaling up to tree applications would be that you made your little valve opener a lot larger so that it could handle, the necessary GPM to handle that one row of say 300 trees.
Yeah, we would put probably a pressure regulator to bring the pressure down, so the valve can handle it. And then if you have street pressure that can reach the irrigation point, the pump unit will transform into a basically on-off switch.
Yep.
And which we do have. We actually have a pinch valve in there right now. The pinch valve is to cut the siphon effect from the tank. So the pinch valve could be on-off. It's already there. We just have to eliminate the pumps. And I guess, so maybe it's just eliminating the pumps, using the pinch valve and changing the software, and we can adapt this for trees. I mean, for long rows of trees, regulating the pressure. That's totally viable, actually.
Sweet. And again, just for the audience, you came from the computer world or
industrial control,
So you understand the nuances of potentially shifting for different types of use for this system, which is fantastic.
Yeah, actually, you just brought something up that's very interesting. The peristaltic is really for micro irrigation, but for macro irrigation, which is trees, we can just use same enclosure, same everything. We drop the peristaltic pumps. You use the pinch valve, can handle quite a bit of pressure. We reduce the pressure for each line. I can test that out actually.
Nice.
I think it works. What you're saying is totally viable. The only thing we have to verify is the distance from the sensor to the. In fact, I can do that right now while we talk. But yes, I think it's totally doable what you're saying. The peristaltic pumps, I can, yes, everything works.
And you could technically,
yeah,
because it's radio frequency, you could set up your monitoring systems. For every 6 trees, you have a new monitoring system, but it goes back to that one pinch valve. So it's keeping track of, like you said, 64 individual metering units are controlled by that one pinch valve back at the beginning of the tree run.
The radio is relatively inexpensive. The circuitry to measure, how far do you know? I mean, we're looking at specific applications, right? In fact, I think I have information about that. Typical. They're all mostly the same. All these uh, like nut farms, right? Pistachio
Yes.
farms. I think they're all laid out mostly the same.
Yep, they are. And remember, I'm thinking about this not just for nut farms, but also, like high-end landscapes where this would be phenomenal because the
That's
problem we
true.
have with present day irrigation is you've got no monitoring. You have no idea this plant is soil type is a little different than the plant 6, 8 feet from it. This one needs more water, that one needs less water, and there's no control over it, which is really problematic on some of these projects. Down here in Southern California because you're either overwatering or you're underwater. Underwater,
Hmm.
you just
Hmm.
can't get it right. And so, people complain like, well, why is this tree struggling? It's like, well, that one's getting soaking wet and this one's not getting enough.
Yeah, the terrain matters. The whatever the soil structure under it matters.
Yeah,
Everything's different from tree to tree.
yeah, totally. So that's where I was like really excited to get you back on to see, you know, where you've come
Man,
to
this
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 point.
this is actually very valuable what you're saying.
Yeah,
Um,
the beauty of it is you can scale up to those nut farms and you can just use your existing system on some of these landscapes where, perhaps you're not monitoring every plant. Maybe you're monitoring every other one so that you can get a greater use of the system. You don't have to like it's not like a container system. It's more of a just every other plant, and you're going to get enough information to know what you need to know to make for the system to make a decision as to whether to water or not.
do you know how far away these trees are? Let's say
So
I
the
think
the typical ones that I've seen, I'm pretty sure they're like 12 feet on center, trunk to trunk, and then they prune them back. And that would go with citrus, that goes with avocados, that goes with nut trees. So it's pretty consistent. I have seen them plant them closer and then come back and cut them down, cut every other one down. In the case of like avocados, I've seen them plant as close as 6 feet on center. But that goal is to once the trees fully mature and they start to grow into each other, then you're just going to chop down every other one. I'm not sure how cost effective that is, but because people are doing it, there's got to be a reason why they're doing it, right?
they
So,
say so it's 17 to 20 feet between trees in a row, and
well,
then
it's about
22 feet between rows. Or
between rows. Yes, there's always enough to get a vehicle down there.
right.
So yeah, generally 18 to 20 feet apart.
The sensor is 5 feet, the wire,
Yep.
and we're probably going to put the sensor somewhere in between the drip line. Not exactly at the drip line, probably in the middle between the trunk and the drip line, somewhere there.
Yep.
Um, Maybe two-thirds away. Probably you're going to use some golden ratio rule or something like that because it's nature, right? So it's going to be somewhere away from the trunk, near the drip the drip ring. Probably, I can talk to the I know the owner of a of a barometer. He probably knows the exact place where that sensor should be.
Yeah. No,
Uh,
I'm confident that it is 2/3 of the way out from the trunk to the
Somewhere
drip.
on there, I agree. Somewhere on there is probably the ideal place. At least 5 foot in the middle, 5 foot in the middle. So you would have we can we I could definitely um, 100% we can do this. I'll show you why. I'll show you why exactly. I actually foresaw some of this when when we originally did the change to aerometer. I thought that in the future we might need um, to support other sensors like capacitive and other type of because the medium, right? The watermark sensor works best in soil, but it's not so good. I mean, it won't work in rock wool, for example. Okay.
Or potting mix.
So in rock wool, you need a three-prong, um, sophisticated sensor to measure really well in the rock wool. So um, the board that reads the sensor, it's an independent board to me. So I can actually take those boards and put them in an enclosed unit and stick a radio in there, and then put a little photocell in between, and we're done. That takes care of the sensing problem. The plant unit won't have the sensors anymore. We'll only have the water lines.
Yep.
With a photocell for moving the valve. So not all of that is passive. No electricity, no batteries, nothing, right? Just a photocell to power it. And then the plant unit, we remove the peristaltic pumps. We use the pinch valve for on-off, and we're done. That's this. In fact, you know what? I'm gonna eliminate more radios. We can do RS-45. We'll do wire in between. So we can take one wire with different stuff. I mean, if I know wireless is better, but we could have a wired option as well. It'd probably be cheaper.
There you go.
To do RS-45, one wire for 8 trees. For 8 pairs, 60 for one row. Do you know how long the rows are? They're probably hundreds.
They depend, but you can always add another unit in. So if you go over 64, just add another unit.
So for sure, RS-45 can do I can do the calculation, and if not, we'll use the wireless. The radio is a little bit more expensive, but the radio will work too. And some of these, I mean, if we can get some actual dimensions, would be cool.
Well, they're going to vary from orchard to orchard. I can promise you that. The land is never perfect. It's not like a football field. It's got angles. It's got.
It would be nice to know, like, what's the acreage, like the typical size of these.
They're all over the map. There's
right?
thousands of acres, and then there's ones that are 2 acre or 1 acre. Or
really? There must be like a minimum to make it economically viable, right?
No, because they're dude, you wouldn't believe that they just stick these trees in all over the place, but they're always spaced 12 feet on center with an 18 to 20 foot wide row. So that's standard, but like it doesn't matter how odd shaped the lot is, they just extend the row as far as they can and then they stop.
Mm-hmm.
If you fly over it, it's almost like a painting. It's actually pretty cool to see because you can see where the agriculture stops due to a road or due to a housing development or due to a drainage ditch or whatever the case may be. But they go for, as long as they're spaced that way, they go as many as they possibly can. And the same with the strawberries. It's like crazy how they'll put angles on the end of the strawberry beds so that they get. And they plant 4 strawberries in a bed, but like they'll get more strawberries on one side of the angle than on the other. They don't mess around out here. So is there any more part of that presentation that you thought was applicable to this conversation today? Or do you think that the rest of it was more focused toward container growing?
The rest is more information about the architecture, like, the radio communications is all encrypted. It's a very sound architecture, very reliable because there's all the control software is completely isolated from all the Wi-Fi or IoT stack.
Okay.
So even if, there's no virus possibility or nothing that can contaminate the basic control of the irrigation. If you lose the network or it won't stop irrigating, so it doesn't depend. Once you set it, it'll work like a PLC. like a programmable controller, it is a PLC.
Yeah.
The part that controls the irrigation as such is microcontroller, all programmed in C. It doesn't see the outside world, except it can communicate with the outside world through very specific channels. But there's no dependence on the like the IoT or anything. Okay, so once you program it, that thing is completely autonomous, which is
Really?
what you want in an environment. You want to leave that thing out in the open. The other thing that is secure, that all the communication between the radios is completely encrypted end to end, and the encryption key is not even known by the company. It's generated randomly inside the system, and then it's shared with a key sharing protocol that we have when you pair the units among themselves. They have a secret channel. They can exchange a key, and from then on, like, we don't even know what the key is. So the possibility of sabotage or hacking of your system or whatever is practically non-existent. Um, what else? I mean, there's a lot of like you said, we were working for years on this, and I think we have a pretty solid product. The electronics is pretty simple too, so it's not um, it's not that prone to failure. Um,
Which is
the,
why I've always loved what you've done. Is you've made it so simple, stupid that you don't have to worry about like over-engineered nonsense that complicates problems and creates problems. I mean, I love the fact that you 3D printed the valves, and that if something breaks, you can just replace it in the field. You don't have to send the unit in to get fixed, and it's not extremely costly because you're using high density plastics, which maybe you could talk a little bit more about.
Yeah, we're using basically ASA. That's a very tough plastic that can resist, mostly for the enclosure part. Um, and there's some polycarbonate in there. There's let's see what else I can. I wish I had this over my head, but
It's all right, buddy. Look, don't worry about it. Like, bottom line is we're just
PETG. So most of the system is PETG. But yeah, I mean we will give the customers all the STL files of the system. So anything that breaks, you could actually go to the library and print it, even on PLA, and it'll work. Then you can replace. You can buy the part from us or print it yourself. So we strive for the whole system to be able to be maintained by the grower without vendor lock-in.
Yep.
So yeah, you'll have the ability to print or replace any part, whether you buy it from us or you print it yourself. And also, we want to allow people to hack into the system. So registered customers, I mean, people that actually buy from us will get the source code, and they can hack, at pleasure, with our support. We want to have like user communities where you say, oh, I did this enhancement or whatever. We think we should work better, or I discovered this way of, I don't know.
Yeah. Again, it's more of an open source approach to business, which I loved.
Yeah.
You're not all about trying to create the next billionaire. You're about like, hey, we need this. Water is becoming a more and more expensive and limited resource, and you can actually make your crops better, stronger, and produce more by giving them these little stressors during the season. And again, this was stuff that you and I chopped up. I don't know. When did I meet you? Like 8 years ago or something crazy? It's been a minute.
I think that I first came up with the idea like in 2016 or something like that.
Yeah. And I think we met
2019,
probably
2019, 18, 19, around that time.
Yeah.
Right before COVID or right after COVID, yeah.
Yeah. So again, you've had all this time to tweak and revisit and perfect the machine or the stuff in a way that, again, is you're making it low tech, low maintenance, easy to operate, easy to use. And I love the idea of creating a community around it where, because you're allowing them to have the access to program it and to play with it, that everybody will learn as a shared group, which is, even more powerful.
In fact, the product has been shaped over the years because of user feedback and ideas with programs like this one. You know, we like. I'm not in a hurry. I've never been in a hurry for this thing. Fortunately, I don't feed my family from the sales of this product yet. So we've had the time to like really sense them or understand the grower, and talk to many different uh, growers from many different fields. Obviously, we started our low-hanging fruit was cannabis at the beginning when the cannabis boom here, and we learned a lot from that community. But learned a lot from tomatoes as well, and from vineyards, and from I went to Spain and looked at the truffle orchards, and I went I've been around to like understand what are the different needs, and we made the product in a way that we can adapt the architectural basics of the product. We can readapt them like we're discussing in this conversation right now. Like it is quite viable to uh, retweak it for the tree scenario for pistachio
Yeah.
um, farm, right? And this is exactly why I want to make it open source. It's because everybody's going to have a different. They're going to want to customize. They're going to want to integrate it with the current system. Like if you have a guy that's already using some control system for lights or for CO2 or their HVAC or whatever, you don't want to be isolated. Like you want them to be able to integrate it into their existing
SOPs.
right?
Yeah.
So you have to be open. Not being open is kind of stupid, you know. So
So let's talk a little bit about production. Like, how close are you to actually being able to punch out a test unit?
I can manufacture short runs right now. I
Okay.
have I have like a small prototype factory, let's say.
Okay.
So we can turn out some units for testing in the field. Um, and then, whether it's from a, let's say, a pre-order, or whether, like, my goal right now is to get it field tested by a few growers. Um, but I think the product is solid enough to even retail sell it off of Amazon or whatever. But
I'll be honest. That was one of the reasons why I wanted you back on here, is because you have no idea how many tent growers there are out there. Like, just millions of them.
yeah, that's
And
why I wanted to keep it. I wanted to keep it cost effective at eight plants.
yeah, which makes all the sense in the world, because maybe they're only going to grow 3 or 4 cannabis plants in their bed, but they're also growing other things. Like I because I'm part of the cannabis community as a result of the conferences that I put on.
Yep.
I get hit up a lot from tent growers asking for different advice and new tech for specifically for them to make it easier. That was one of the reasons why I preached the horizontal zone, is because now you don't have to be there to water your plant every day or to watch your plant. Like, so many people have called me or DM'd me to thank me. Hey, I was able to go on a 2-week vacation for the first time in my life and not freak out about coming home to dead plants. And this takes it to another level, because not only can they monitor it remotely, they also know that it's so basic that it's not going to break down on them. And now they can extend their vacation to a month or go travel, backpack, bike, hike, whatever, which is fantastic.
Do you know Do you keep tabs? I mean, do you keep contact with people that have switched to Soul Horizon systems with cannabis?
I haven't, but let me ask you this: will the tent lights, whether they're LED, they're
Yeah,
usually
they can power the thing. Yeah, but still, you have an AC plug there anyway, so that's not a big deal. Inside the tent, you're gonna have electricity somewhere.
Yep.
So yeah, I did tent here. I started designing the product with pepper plants.
Yep.
I don't know if you remember those pilots. For years, I did like easily 4 years growing peppers with this system. So the system's actually being tested for real, and that's why I discovered the UV light destroys the plastic, and you know the heat requirements are pretty high. So there's a lot of things I learned from that tent growing experience, and it would be amazing to find somebody that grows in a Soul Horizon system inside a tent, and we could give them the watermarks, put them in there, and right between the near the A layer,
Yep.
to get sandy loam or loamy sand area. Um, that would be an ideal place to. I would love to see a, a guy crop steering that, using a Soul Horizon system.
Well, you know what? I think I have just the right person for you.
And do they do it in pots or raised beds for Soul Horizon?
He's raised bed horizontal soil.
Okay. Do you know how many plants he has per bed?
He's in a tent, so it would be the ideal, totally controlled environment to be playing around in.
The biggest tents are like 888, right? So, well, no, not really. The biggest tents I could fit in my house were 888. But
Yeah. They're usually 4x8 by 7 feet tall or something.
I had an 8x8 here, or 7x7x8 or something. It was pretty big. It occupied the room. I'm in the basement right now. It occupied the complete room, and I had like in a bed there for cannabis. You have to space them quite a bit. What you have usually, what you can fit like 5 big plants there, right? Not more than that. Maybe one more. I don't know.
Well, usually what they'll do is they'll either stagger them, so 2, 1, 2, 1 in a 4 foot wide bed, and that's infinitely how long. Some guys will just do 2 plants and then try to thin out the middle so it doesn't get too problematic. But I think the ones that I've seen that were most successful were actually staggered them, because then they could get really big.
So that's probably 6 plants in a bed on an 8 foot tent.
Yep. But the other thing too is that, I'm always telling people, I really encourage you to grow other things. Grow some potatoes, grow some flowers, grow things that you can use, or herbs, right? Everybody needs, freaking basil and
you know what?
cilantro.
Business saffron.
Oh my God, saffron's crazy.
But it's very very economically, but you have to grow a lot. But in controlled environment, it's probably a good idea for saffron. And also, I did the numbers for the real wasabi plant, not the stuff that you get at the restaurant, but the real wasabi root. That is a good. If you can find somebody that is interested in buying the actual, restaurants don't serve the actual wasabi; they serve the horseradish. For the most part, or this green paste that is not actual. But the real wasabi is served with the root and a little what do you call it?
The stalk?
No, forget the name in English, man. Hold on.
That's all right. It's basically the plant.
A grater.
Oh, okay. The root and a grater.
Yeah, and the people grate their own. It's like fine Parmesan cheese.
Yep.
Like they grate their own wasabi, and that's the way it's supposed to be eaten, not that green paste that you get. So if you can find somebody that can buy you that wants to um,
Grow the wasabi root.
or a restaurant that wants to present the wasabi root with the grater like they're supposed to, you could they have to import the wasabi from Japan. Like there's nobody that's growing um, wasabi anywhere else. It's very hard to grow in CA, but it is doable. There are people that do it.
So
And this system would be ideal for this.
Is it restricted? Like, can you get it? Can you get the starter seeds or whatever?
You can get the seeds. You can get the seeds and everything. It's very, very hard to make it grow in the CEA. But with a system like this, you probably do it.
So in a controlled agricultural environment, you could grow.
Totally organic. I'm pretty sure you could grow with the hydrogrid system growth, because it does require very particular moisture on the soil.
Gotcha.
So the conditions are very have to be perfect for the thing to grow. This would be ideal for growing wasabi, and wasabi is a very cost effective, how do you say that? Very expensive crop.
Yeah, high value cash crop.
High value crop, yeah, cash crop. Yeah, I've been thinking a lot of making my own grow and just eating my own dog food with the system and growing something myself. I love the peppers. I think peppers is still. I love growing peppers, man. And I love hot sauce, and I love the heat. I was growing these ghost peppers and scorpion, and I found all these wild seeds that were really, really hot. And when I applied crop steering, you could see the difference. I have some pictures somewhere. Crop steer and not crop steer plant in the same tent with the hydrogrid.
Is it up on your website?
No, I can find it here somewhere. I know I have it because that's one of the experiments. One of the experiments I did was control plant, no crop steering, water irrigation, like keeping it moist or whatever, and then the other one with the hydrogrid system. And I have pictures of the yields on both plants, and it's dramatic. The difference.
And I remember you telling me that the system, your system, produced a lot hotter of a pepper, of a fruit.
Well,
so
the quality, everything, yeah, because when you restrict the plant from the water, it concentrates everything on the fruit, right?
Well, that's the thing about stressing. If you stress something,
you get the better product. Yeah.
You get a better product, absolutely. Yeah. Let's face it, nature doesn't make everything perfect, right? Nature stresses the plants naturally through seasons, through temperature, through wind, through rain events. So it's never the perfect environment. The plant is always adjusting to something, and that's how you make a stronger plant.
I'm pretty sure I have them here. Oh yeah. In fact, I think I can upload these. Traditional irrigation schedule. Yep. I wonder if I can upload, present, image file. Okay, so I have to export these. Yeah, I can do this. Give me a second.
Yeah, no worries. So there was a question about whether you are available here in the U.S., and I believe you can.
Well, we're not manufacturing yet, but if to sell in the U.S., we'll probably start manufacturing here. But the manufacturing plant can be set up very easily somewhere else.
But you can ship to U.S., right?
Oh, 100%, yes.
So yeah, so it is available microfauna.
Yeah, we'll see what the tariffs do to the pricing, but I don't think it'll be much. And if it is a problem, man, we can manufacture. I mean, the manufacturing facility is really easy to set up.
Yeah, it's a 3D printer, right?
Yeah, and the electronic robot. I mean, there's we also manufacture electronics. We don't like we do the manufacturer end-to-end.
Gotcha. So you're doing both the circuit boards as well as the
CD. Yeah, everything. Final assembly. We manufacture the whole thing. Nothing's made in China. well, except the parts. Let's see.
And listen, I want to be considerate of your time because I know you're on the East Coast, so it's pretty late over there. It's probably dinner time for you at this point.
I know it, man. This is actually a privilege for me. So, help ever apply traditional aviation. Okay. So,
Yeah, super nice. So this is exactly why I've been bringing Alex on repeatedly onto the show, because there are so many applications for this. And look, Alex has been working on this for a long period of time. He's got to feed his family, so it's not like he can focus full time on this. But I keep bringing him on to encourage him along the path of getting this to market. So yeah, keep your ears open. Like, you can follow him.
He's only an hour from Toronto. He could actually talk to go and see Alex.
Well, there you go.
Who was that?
The gentleman at Super Nesso 83.
Oh yeah, for sure.
Yeah, they actually have to truck water into the reservation to have good, clean water. And if you're doing this, then it can be really beneficial to them. But I see your pictures, so I'll add those up to the stage here.
All right, so that's the traditional irrigation. You can see the pepper there is green and whatever. There's a few peppers there. Let me upload the other one. Crop steer.
Do you have a
crop steer
Instagram account or Facebook account?
Dude, I don't do Instagram, man, but I should. I do have it, but I don't use it. That's a very, very bad. I should probably put all that stuff up there for people.
Hell yeah, dude! And then
look at the difference.
And then like, flag people like me and these other people, and your word will get out, and then you'll start building demand.
Yeah, I've been cautious with demand because until I was ready to produce, I didn't want to make a lot of noise. I just wanted to sense, what people were thinking. But here you have a comparison, direct comparison, the 60-day crop steered versus traditional hand watering. And you can see the yield, the size of the pepper, the color, and the amount of peppers on the plant is totally different. And this was one experiment, side by side. So we had a control plant and no control, and we had and we did this for years. So I tested the system quite a bit with peppers, but there's a lot to learn when the customer gets their hand on the product, right? They're never going to be as careful as we are, with the. So I do want to. I'm doing destructive tests, by the way, before we actually put any unit. I thought that was actually cheaper than doing a pilot. So I think I got a new mentor on board, and we're looking at ways how do we commercialize this without a huge amount of capital. And two ways: either we invest a long time, 2 more years testing this thing out with actual growers, or let's say the alternative is doing destructive testing here and just selling it directly afterwards. Like if we know what the mean time between failure is, and it's high enough, then we can just ship as is. And what I don't want is the product to fail in unexpected ways, because maybe our testing is too. If you build a product, where it's weak. You're never gonna break it on purpose, right? But consumers completely different. Consumers gonna operate whichever way. They're not gonna be necessarily careful on the way they unplug the.
Well, that's why you get it in the field. It's called field testing.
Yeah.
When you say destructive testing,
Yeah.
As soon as you get it out in the field, the sooner you start to learn the weaknesses or perhaps the strengths of it.
Yeah, there's a bunch of stuff that, like, we know uh, the the things that are wear and tear. For example, we started noticing at the beginning we used brush motors for the pumps, and over time you can feel the difference. You can see the brush motors are, they tend to um, wear out over time. So it's almost like a consumable, and they give you what 5,000 hours maybe. We changed to brushless, and it's a completely different things, like 30,000 hours between.
Yep.
Right. So I it's all, and the difference is it might be double for me in cost, but it's well worth but the difference is like $5 to $10. So it's not. I mean, it's double, but it's peanuts, you know. But those are the decisions that you learn over time. Like, you only invest a little bit more in a higher quality component, and you get 10 times, orders of magnitude more in the meantime between failure.
Hey, Alex, how can Super NES 83 meet you or connect with you? Do you have an email? Do you have an email?
There's in the agrome.com page. There's a contact form.
Beautiful.
I mean, hey, I saw you in Soil Matters. Send me your contact info, and I'll ping you back. I get those emails. There's a contact form there. The website is a little bit very technical right now. It was I've never updated for a while, so. But this is more like an insider's view. Everything when I talk to Leighton, we're completely open. How you say open books here, right?
Yep.
We're not pretending, to have something we don't have. So I will update the website with a final prototype soon. I did a little staging picture for this presentation, but I want to do like a professional one, and start that ball rolling for selling the first units. I'm very interested in the tree thing because it also opens up the other market that I'm telling you with the truffles. Truffles in Spain are the decrease in yield is substantial, like 20 or 30% right now, because of climate change. Whether or not it's man-made, I don't care, but it is a reality for them. Okay.
Yep.
And the climate's going to change all the time. I think it's just crap that we're just calling it something right now. But
so, Alex, out here in the Central Valley, which is millions of acres, right, of some of the most fertile land, it was the breadbasket of America.
Yeah.
Forever.
It's the economy of the world, man.
Yeah. So, unfortunately, due to the fact that they just suck the groundwater down so low, the land is actually sunken, many feet. And basically, they've created green zones, yellow zones, and red zones. Red zones don't get water anymore. They've shut them off. The yellow zones are restricted water. The green zones are kind of okay corral. They can pretty much do it.
We can help there, man. This is a product to help in that.
Oh, dude, in the yellow zones, especially where they're limited on how much water they can use, they are going to have no choice. And this is why, I reached out to you a couple of weeks ago and said, dude, I got to get you back on because, if we demonstrate in a green zone how well it works, where if something happens and it goes wrong, they can pick up the water right away. But if you demonstrate the ability of this being bulletproof in the green zone, where you can't make a mistake, you can't kill anything because they can switch back to regular irrigation in a heartbeat. Then you roll out into the yellow zones where you can reduce water by 50, 60, 70% based on how else they build the organic matter in the soil. The results are going to be insane. And then maybe someday, if we tweak this to the end limit, now you can bring life back to the red zones because the yellow zones aren't even using their requirement. So now that some of that water can get pushed out into the places where they're getting no water. And that, to me, is something that I would love to see, is the restoration on the soil in the Central Valley in a way that they're not nuking it with fertilizer, because that's the other side of the coin. If they're using nitrate fertilizers, water has to be present in order for that nitrate to be consumed by the bacteria.
Well, with this system, man, we can put we can do fertigation.
Yeah.
You put the fertilizer in the water, so you use much less water.
Yep, and much less fertilizer.
Yeah, and instead of fertilizer, you can use, aquaponic waste and stuff like that. I mean, there's ways to.
So
organic. Did I tell you about the guys? Man, if we're doing this, I will definitely come up with a way to do this that we discussed today that is minimal change, but I take the sensing out of the plant unit and distribute it in a much wider area. Okay.
Yep.
I'll do that because I think this is very important, and it's probably the first market that can actually put a purchase order down and get me producing, right?
Yeah,
So,
if you proof this out, there are groups up there that are self-controlled. They're like a community. I forget what the term is, but it's all wealthy landowners that are protecting their own interests, right? They're so powerful that they have lobbyists, and they're not governed by corrupt.
their own. It's private, man. They
do what they want, but they're always looking to find new and better ways to do what they do. And so there's this other company called ESS, Ecosphere Sciences. I've been working with them for 3 years now. I think I told you about them. They produce a food waste fertilizer that's not only a fertilizer, it's a biostimulant, it's a bioinoculant. So it's producing the protozoa and the nematodes. It's a biostimulate, so it's stimulating the indigenous biology. It's got hormones out the yin yang. So, whether it's plant growth promoters or, pest resistant, just the recent tests we did. Well, let me finish. It's also got extra polymetric substances, which are biofilms that help to create soil aggregates, which makes soil go away from compaction into full function, right? And dude, we made aggregates in contractor sand, little nuggets, little friggin' aggregates in sand. We doubled the clay and we took 5x more silt in the sand using biology. There's the experiment. Look on the bucket on the left. 4 inches of topsoil, dude. 4 inches of topsoil out of sand. It's insane, right? So the power of this product combined with the power of your distribution system could start taking back parts of the red zone once the yellow zone goes into a position where they're not even using their allowed water. So, the future is bright, but we need systems like
somewhere, yeah. And
we need systems like you created that function. And again, you're not trying to make billions of dollars off the backs of these hardworking farmers.
Yeah, no, we want to be part of that solution, not. So, do you remember the guys that I told you in the UK? I think they're called Soil Ecology Lab or something like that.
Yeah.
They made a product that is 1-to-1, 1 sack to 1 sack of fertilizer, of NPK or whatever. They made it 1-to-1 ratio so the farmers didn't have to think. And they create this live product that replaces fertilizer completely. And the results are incredible. And it's all live biology. So they restore the biology in the soil. Even if you till, they don't care because they're going to pour this thing back into it. So what they're trying to do is they're trying to make farmers switch 1-to-1 without changing their whole mindset. It's very hard to get the farmer to change the way they're doing agriculture, but it's easy to get them to buy a different product if it's compatible with whatever they're using. So they came up with a way to replace on a 1-to-1 ratio whatever the farmer's using today. Uh, you have to talk to them exactly, what it is, but um, they basically revive the soil with this live product that can be used seasonally, like for every crop, even with tilling. So they're able to bring biology back into the soil, and that brings all the nutrients back into the soil without adding NPK.
Yep.
And they add this product that is compatible. It's not compatible, but it's quantity-wise the same. So if the guy was buying, I don't know, 100 sacks of NPK or whatever, they just buy 100 sacks of this stuff, and they just replace it 1-to-1 in their equipment. They don't have to change anything, not even their practice. They can still till, because when you till, you're destroying a lot of their, especially like the mycelium roots and all that. But they don't care. They just pour it back into the soil, and they're getting very good results. So products like that, combined with smarter irrigation, that like we have the tools to fix these problems and to reduce the amount of water to a minimum. It's just a question of putting it together and showing, here's a prototype, it can be done. And most definitely we and imagine if you take this a step further, which is talking to the biology itself, which is something that I have on my roadmap, as we discussed last time. You remember that paper? Did you share it with the audience at that time? The paper with the guy in France that has decoded 50 words of.
Yeah. We posted it. It up. I don't know how many people actually read it, but
so
no,
this guy is able to talk to fungi.
Yep.
Well, he's able to understand it. He's not able to talk to it yet.
Yeah, right. But they will be able to. And this is it, dude, the stuff coming out with large language models.
It is well known that somehow the mycelium in forest is able to redirect water from one place of the forest to another.
Oh yeah, there's videos of it.
So can't that be done with the red zones?
With the you mean with Mike?
Could you move water from the green zone to the red zone?
Yeah, absolutely. But again, you got to bring back nature.
Yeah,
right?
You got to bring nature into the equation.
So you got to break up the roads. You've got to create these green zones for the fungi to travel between the yellow and the red zone. Mm-hmm. You got to be obviously nature. Respect nature instead of just consider it to be dirt. So you'd have to change a lot of people's minds, but it starts with one spark, dude. Mm-hmm. And guys like the dude over in France and all the other LLMs that are developing this understanding of through music, right? And your dude, I think, was the same thing. It was through tones that he was realizing, oh, I hear this tone and this happens. That's a word, right?
He measured the electrical pulses over time.
Yeah, it's a pulse, right? It's the same thing as a musical note.
Yeah.
So
once, 50 words.
Once these bridges come together and they start to realize they're doing the same darn thing, and I know this and you know that, but let's talk together because together we're smarter than we are individually. Then all of a sudden this stuff is going to blow up, unless it's being held back, which is a whole nother thing. But bottom line, either way, you are one of the cornerstones or foundational pieces to this puzzle, because if we have the ability to seriously reduce our water in a way that we're not only reducing it, but we're getting greater yields and healthier, stronger plants, and that means less inputs, less problems. Dude, I was at this orchard up in the Central Valley walking around, and there had been 2 applications of muncher juice on it. And I was looking around on the ground, and I've seen all the different types of ants. They have red ants. They have those highly evasive black ants, which are, talk about nature's friggin' survival. Yeah. These guys are so crazy that they'll join each other's colonies without killing each other. So you kill this colony, whoever lives will go to the other colony and start working with them. They specifically harvest, a certain type of mite that they bring with them to the top of the tree and put on these little leaves, aphids. They put these aphids on these little leaves with the new shoots that are coming out, and the aphid eats the leaf and poops out honeydew. Well, the ant wants the honeydew for its hive. So they're literally using these aphids to farm food for themselves off the new tiny little shoots that are coming off. Highly destructive, because that's the plant's future. Like, imagine if you killed every child that's born, right? And so I'm scouting these trees, looking, high and low for these aphids. I couldn't find any. And I started thinking, well, maybe the red ants are keeping them at bay. Finally got someone to do a Brix test on it. Control versus the treated. Control was 14, which isn't bad. That's really not bad for a minimum use NPK farm. But the muncher juice after 2 applications, 22. Dude, above 20 is considered pest free, right? And that's only 2 applications. So imagine if there was 4 applications or 5 applications. I actually asked the guy, texted the guy, he still hasn't responded. I'm like, what is the highest Brix reading you've ever seen? Like, what is the limit of this machine?
How does it work?
So it works using light. So you squeeze out sap from the leaf. He's got the special grinder and the special press, and you squeeze out a little bit of the sap and put it on this meter, and the light reads it, and it tells you what zone it's in through color. And so when you see the higher frequencies of color, you have the higher, the higher the waves, the higher the frequency of the color, the higher the Brix is. And again, I don't have all of the science behind this.
Okay. No, but and how does the product prevent? How does it kill the?
It makes the tree so strong that the aphids can't eat it. See, if the cells are so strong on these newly tender little shoots, which are usually the weakest part of the plant, if those cell walls are so strong, the aphid can't penetrate it. Its little friggin' sap sucker can't get in there. It's too strong. So here again, these are things that with your system could be coupled in a way that not only cost effectively delivers the product, but delivers it with the water. That's a whole step saved. These farmers have to go out and jack in, the product into these streams or into the water treatment system so that they can inject it out. That's a whole job in itself. But if the units were set up so that the injection material was already on site and the guy didn't manually have to do it because your controller did it and blended it to the right blend, dude, think about that, right? That now the farmer can just run around and drop off totes at every single one of the sites and do 50 fields when it would have taken him do 5 fields.
The whole design is to reduce labor. Right?
Yeah, that's what I'm trying to explain or trying to say, although I'm bumbling around.
Yeah, 100%. I understand 100% what you're saying.
Yeah, I'm excited, dude. I'm really excited.
Yeah, man, I'm going to go in that direction. It's a subtle change. It's not a big deal. I think we can adapt the product, the same production line, everything, just changing a few things here and there to make it based on that you have a water pressure line nearby.
Yep, and they always do. And the infrastructure they have is insane. It's absolutely insane. It just needs the brains to friggin' tell it what to do and when to do it. And all they'd have to do is drop off the tote, connect it, through a venturi, and then as the water goes by, it pulls in a certain percentage of it.
Mm-hmm.
No pump. So I'm trying to get you fired up, bro. Like, it's time. I need your help.
Yeah, man. No, as you saw, the thing is there. It's not a theory anymore. It's not, it's not an idea. It's concrete product.
Yep.
And I can actually build it. So
start thinking about putting together like just a small unit, eight trees, We'll demo it up there to this guy. Get it down to me as soon as you possibly can, because I going up like once a month, just to kind of monitor progress, do direct microscopy, look for plant reaction, look for insects, stuff like that, scouting. So if my next time up is in probably 2 weeks, and after that it'll probably be a month after that. But if you can get one put together in the next 6 weeks, I'll run it up there and get it set up and get you in contact with the farmer. He's a real busy guy, but I know that he will take the time to talk to you, especially if you answer his questions. Then he'll be wide open to it, because I already mentioned it to him that this was that I knew this guy Alex who's invented the system. That
is there a signal up there when you go? Is there like a cell phone signal? Can you?
Yeah, hell yeah.
When is the next time you're on?
About 2 weeks.
All right, so we can maybe when you're there, we can do a video call, and I can look at least understand what the
absolutely.
Look like.
Yeah, I'll give you a tour of the orchards. We can measure the trees just to verify that they're 12 feet on center, but I'm pretty comfortable that they are. And the width of the roads are 18 to 20. I could show you the irrigation systems. He's already got a ton of monitoring up there now, measuring potassium, nitrogen, water, moisture value at different depths, through the potentiometers. So he's definitely like going in the direction of really trying to partner with the soil, partner with nature, not try to control it.
Tensiometers are manual tensiometers, like aerometer tensiometers?
No, he's got some pretty sophisticated ones. I'm not sure whether the actual head is an aerometer head.
Aerometer has a transducer that does electronic too. So
yeah. My gut feeling is it's the transducer version of it, because everything comes through on a graph on his phone in different colors. Each color is representative of a different function. So everything overlays onto one screenshot, so you can really like read everything that's going on one view or whatever, one screen. It's pretty sophisticated shit, but yeah, I'll definitely, when I get up there, I'll definitely video call you and we can walk through it, and I can show you the different things and what's going on.
Okay, man.
It'll probably be short, dude, because it's hot.
Yeah. No, I just want to physical idea. Maybe I should fly over there when you're over there.
Yeah, I'll probably be videoing you out of my air-conditioned car. Dude, I've gotten so bad. Like, I am so friggin' spoiled. Temperature gets over 80, I start sweating. If it gets under 60, I'm chilled. I used to be able to do friggin' negative 20 in Vermont in the winter, and 100 plus degrees with 80% humidity in the summer, and I could just punch through it.
80's a bitch, man.
Getting old sucks, dude.
Yeah, it really sucks.
But anyway, why don't we wrap on that note? That I'll be back in touch with you in the next couple of weeks, and I'll text you to let you know, because I'm waiting on him to tell me when to go, because he wants to get me there at a specific time, 3 to 4 days after they start harvest, so that I can walk through some of the other ingredients or potential ingredients that we can use in the muncher. And then also I got to do, a catch up on the second application, see if they've established protozoa. So it's going to happen. It's just a matter of when.
Yeah, this has been great, man, because I think that a version without the pumps is really powerful, and separating the sensing in a way that's more geographically distributed, so we can have a much bigger and make everything 3/8. So instead of the 1/4-inch lines coming out, we'd have 3/8 lines coming out directly.
Well, that's the beauty of it, is all you need to do is control the solenoid that controls the on-off for the water.
Yeah, no, it's a pinch valve. I have the pinch valve right here. It's
that's all you need is that pinch valve, and everything is all the irrigation is set up, so it's just a matter of plugging that pinch valve in to the start of each block. And if he needs to cut a block in half because it's got too much pressure, he's got extra irrigation lines.
No, we can put that down. There's regulators for that.
Yeah.
That's no issue, man.
Yeah, and again, it's all about volume anyway.
Yeah, it's volume.
But anyway, so Ken, we don't have any questions, right?
No, there was just the main one was if you can get it to the U.S. and you can get it pretty much anywhere in the world in short order from what you've done and have it set up.
We'll be producing soon, so I'll probably have it up on like the basic product, not the one we're talking right now for trees.
Yeah,
this is a tweaked version. Well, I don't know, come up with a different model or whatever. It's a variation, but the standard product with the micro irrigation, 7 liters for 64 plants in 8-hour period. That product is ready to go.
Cool. Cool.
Yeah.
And I know Super Ness is going to be reaching out to you for some trialing on the, an hour south of Toronto is where he is in the greenhouses. So you guys can get together.
I'll probably drive up there to his site and, and meet him there.
There you go.
I'll drive over there.
He says he'll talk to the boss tomorrow. He has a few greenhouses.
Fantastic.
Where they're here in Canada, or they're
yeah.
Oh, they're just in the Greenbelt. Yeah, they're probably down somewhere in the Greenbelt where the vineyards are. Yeah.
The Six Nations.
Six Nations. Okay.
Yeah,
man, I could probably drive there. I mean, not probably. I can. I just drive over there whenever he wants.
Cool. Anything you want to add, Alex?
Yeah, the only thing I'm waiting for to publish a product that people can click and buy is the destructive testing. That's something I won't.
Well, he'll do it for you.
He'll do that for you.
We're actually doing that right now. So.
Okay.
Yeah. So there's some. It's still a few things to hammer out, but besides that, we could probably start putting units here and there for testing, and then ramp up production in the market. We don't want to go too crazy and then just fumble. So
yeah,
we want to go little by little. We want to make sure the product works on different scenarios. How it reacts to the environment, what have you. But like you said, we've been testing this for years. I have the same electronics that I'm using for controlling the system. I've been controlling other stuff. Crazy. I know it's not related, but I have external controllers that have been on and off since 2018 approximately, and they've been out in Canadian weather, outside completely during the winter and the summer. So they've been on operating for the past almost 10 years, controlling HVAC units. It's unrelated to the agricultural part, but I just wanted to test the reliability of the electronics itself. And that has been going on for years. So I know that at least the electronic pieces won't are pretty reliable. So,
cool. Gotta like that. Gotta have that foundation really strong, Alex.
We do it. It's all with the constraints of our budget, but we've been doing the right things, the right steps. But
cool.
Yeah, well, thank you for inviting me again. It's a pleasure.
I appreciate you as always, Alex. And your heart and soul and your goal in life. I totally align with. So thank you for giving us over an hour and a half of your time today, and bringing us up to speed. And Ken, as always, thank you for all the work that you do behind the scenes. And I don't know if you had any announcements you needed to make.
Just that on Wednesday, we're going to start going chapter by chapter through Andy Lopez's book, The Invisible Gardener. So you guys are going to want to check that out. It's going to be on Wednesday evenings on Gardens the Untold Story. Other than that, no, we're pretty good to go. Everything is beautiful. The sun is shining.
All right. Hey, bless you soul tomorrow while you travel the dark roads of losing a lover. And know I'm sitting there with you, giving you a hug, and you too, Lil.
Thank you. That means a lot, Leighton.
You're absolutely welcome. You're absolutely
okay, guys. We'll see you in a few days.